I would like to mention, Hans, I love your slides because I couldn't express it better, because we are also a part of this CHP companies who create CHP solutions all across Europe. And not just being Kawasaki gas turbines section, we provide the industry with solutions based on CHP. However, I always have to deal with the question when it comes to all of these buzzwords, when it comes about decarbonization, renewable energies, and all of that stuff. I always have to deal with industrial applications. And if you go, for example, into a chemical plant, now imagine there is a steam generator and producing 200 tons or 250 tons of high pressure steam within 1 hour. Now, the idea is in the future to change this steam generator to be an electric steam generator supplied by ideally green power. Now I'm posing myself the question, is this going to ever happen? Because if you distinguish between industrial applications and private households, the idea that you will going to use green energy for the industry, it's for me still under a big question mark. But this is something that bothers me a bit, and I do believe that the ideas are up to now a bit, I don't want to express myself in a wrong way, but I think sometimes we have to be more realistic and really distinguish between the different sectors, if it's industrial, if it's just private households, if it's mobility and all of that stuff. Now, let me get into my presentation. I'm here today just to show you, since hydrogen has become a declared future fuel for hopefully also power generation, and show you a bit the technical solutions which may be presented by gas turbine manufacturers, gas engine manufacturers in the future. Now, most of you know Kawasaki, most probably because of the motorcycles, right? But as a matter of fact, this company started 130 years ago producing ships. Across the years, we have to manage to expand our business in many different sections. I will not bother you with the details, but Kawasaki Gas Turbine Europe belongs to the energy systems and plant engineering. Kawasaki Gas Turbine Europe is, as a matter of fact, we do have our headquarters very close to Frankfurt City in Germany, and we, by the way, operate an office in Romania and all across European countries. We have a wide range of products when it comes to gas turbines and gas engines. I will not bother you very much with the details, but they are certainly highly efficient and mainly designed for combined heat and power applications. Yeah, what is Kawasaki nowadays doing? You may remember back in 2011, there was this Fukushima catastrophe, which caused the Fukushima nuclear power plant to explode, and it was a disaster. From that point on, the Japanese government decided to change the energy policy, energy strategy for the country and go for hydrogen as a future fuel. And that's the reason why Japanese companies, especially Kawasaki Heavy Industries, started to create technical solutions for a hydrogen application in total. Starting from the transportation of hydrogen, Kawasaki has produced now, the first ship is already, the hydrogen carrier, H2 carrier ship is already in use, the smallest one with 1,250 cubic meters. And you have to imagine hydrogen is, apart from the fact that it's a very dangerous gas, you have to cool it down to minus 253 degrees in order to make it in order to transport it from here to there. And since you don't want to waste this gas and you don't want to evaporate again, you have to keep it on this very low temperature. So you need a lot of very sophisticated technical solutions in order to keep such a ship in operation. And so it took Kawasaki a couple of years based on the experience which they already had in the LNG carriers. So they let's say used this experience to produce the first ship. We are going to also increase the size, and by 2030, this 160,000 cubic meters of volume ship is going to be in operation, hopefully. And this is the inauguration of this first ship. It's already commuting between Australia and Japan because the Japanese government decided to produce the necessary hydrogen amount. It's not the green hydrogen, it's the gray hydrogen. And but if you consider the Japanese constraints, and it's an island with no natural resources, so you have to get your hydrogen from somewhere. And they will certainly not use just renewables in order to produce that hydrogen. So they decided to go producing hydrogen, gray hydrogen, and import it from Australia. So it's 9,000 kilometers. It's going to take you 1 month to transport all of these hydrogen amounts from there to Japan. And you have to make sure that within this 1 month, you do not lose this amount of hydrogen. It shall not evaporate and all of that stuff. So it's really challenging. And this is, as a matter of fact, the first port, the receiving terminal, which is already also in operation. So you may see that we are, as a matter of fact, far ahead of our European, let's say, manufacturers, or we are just starting to think about. Maybe this would have never happened if this unfortunate war wouldn't be now. And now, for example, the German government is thinking about of construction two LNG ports in Brunsbüttel, which is the northern part of Germany. But now you see countries, depending on their, let's say, constraints, they do take action in order to change, in order to go for new technologies. Now, we, as a matter of fact, are the first company to operate a complete CHP application on 100% hydrogen, and that dates back to 2019, based on our smallest gas turbine, because we do believe that the available amount of hydrogen is not going to be that much. So if you want to realize CHP solutions, you have to have a small turbine, because the amount of hydrogen you are going to use is, as a matter of fact, a lot. But this is a kind of demonstration plant that it works. Even though this plant has been operated on 100% hydrogen, just as far as I know, 500 hours, but because hydrogen is very expensive, as you may know. But it works, and we are going to change, hopefully, also the European market in the same manner. But I just want to show you that this turbine can also take each and every blend ratio between natural gas and hydrogen. And but as you may also see here, this is something that is this small turbine needs to take 2,200 norm cubic meter of hydrogen per hour. So it's a lot, basically. Now imagine you want to scale this up, extrapolate to a 100 megawatt or 200 megawatt, 300 megawatt power plant operating on hydrogen. So you are going to use a lot of hydrogens, and you have to have a lot of electrolyzers. If this is going to ever happen, I'm a bit skeptic, but this is my personal view. I don't want to bother you with a lot of details. The only thing, we have developed now 3 different combustion chambers for our turbines in order to take up any, let's say, different fuel ratio between natural gas and hydrogen. But what I would like to show you, I think this is my key message here also when it comes to expectations towards emission reduction. Now you see, within the recent couple of months, also declared maybe by the European Commission, you are supposed to provide H2-ready gas power plants. And you're supposed to use at least 20% of hydrogen. Now, in terms of emissions saving, if you use 20% of hydrogen in your fuel mix, you're just going to save 3% of CO2, and that's it. Now, the story becomes much more interesting if you increase the fuel ratio, the hydrogen ratio, above 60%. Now, I don't want you to be deceived just by the idea that if you are going to use 20% hydrogen, you are going to save the world. You're not, you know. So you have to have not only H2-ready power plants just by using 20% hydrogen. If you really want to become green, and this applies mainly for the industry, you have to go above 60 or 80% of hydrogen. And with those fuel ratios, the technology is going to be challenging and it's going to cost a lot. And now, back again to my question mark, are we going to make it really happen within a short-term view or within a short time to become more green? And yeah, that's it basically from my side.
Thank you.
Keep this figures in the back of your head if you're discussing about